Level 8 Key Stage 3 exam type questions. Got a bar chart about the number of people in billions in the year 1998 and projected for the year 2050, and different age ranges. Several questions. So here it is, ages of the world's population in 1998 and a prediction for the ages in 2050. Use the chart to decide if the statement is true, false, or if there's not even enough information to tell. The percentage of the population that is aged under 20 is expected to be about the same in 2050 as it was in 1998. Under 20s. Well, this is 0 to 19, so this is under 20s, and you can see in fact it is exactly the same. But the question says the percentage. This is saying exactly the same number of people, in other words just under 2.5 billion people. But what percentage? If we look at this, then this is just under half of all those in 1998. So we can say in 1998 the percentage is just less than 50%. Whereas in 2050 the projection is possibly about a quarter. In other words, 25%. I'm sure there are other ways of answering this question, but with a suitable comment there, we can say that in fact the suggestion is false by looking at the actual percentages rather than the number. Part B, approximately, what is the expected percentage increase from 1998 to 2050 in the total world population? So we're looking at 6 billion changing to 9 billion. So 6 billion people in 1998 changing to 9 billion people in 2050. If we're asked to work out a percentage increase or decrease, we're talking about a percentage change. So we put the change over the original and multiply by 100, and that will work out the percentage change. So it's changing from 6 billion to 9 billion, which is a change of 3 billion, and the original is 6 billion. We didn't bother putting the billion because that'll cancel out. So we've actually got this cancelling to a half times 100. So we're looking at a 50% approximate increase expected between those years in the total world population. Part C, approximately what is the expected percentage increase from 1998 to 2050 in the number of people who are aged 60 or over? So we're looking at 60 or over. So this is 60 to 79, so that's 60 or over, and that's 60 or over. So I would say that this is approximately 500 million people in 1998 changing to 2 billion. So our change is 1.5, it's changing from that to that. Change over the original figure is half, and that needs to be multiplied by 100. Well, this will cancel. Don't normally cancel decimals. In fact, I don't think it's a good idea. You should multiply the top by 10 and the bottom by 10 and then consider cancelling whole numbers. It's safer. Anyway, that will cancel and you'll get 3 times 100, so we're looking at a 300% increase. Now I reckon this is a generous question, because it gives you that this is a box plot, sometimes called a box and whisker, for the heights of all the girls in year 7. So if you'd forgotten what a box plot was, a box and whisker, the examiner has been generous enough to tell you that the end, the whiskers, tells you the shortest to the tallest. The start of the box is the lower quartile, the end of the box is the upper quartile, and there's the box, and there's the median. So this is just a piece of information, but the question continues with the information about year 9 girls. So that's the information about year 7 girls. This is the information about year 9 girls. And it asks you to compare the heights. So one way of comparing the heights, or one way of making comparisons when you have this sort of information, is to draw a box plot and then look at the two box plots. So let's draw a box plot, or box and whisker, for the 120 year 9 girls. There is the 60, which is the median. Now when there's 120, you can argue it's between 60 and 61, but it's all approximation anyway, so you don't get that fussy. That's the median. The lower quartile will go across at 30. And the upper quartile will go across at 90. And in the exam, most definitely label exactly as I've done there. Because if per chance you're not very good at the question, the examiner could still give you marks for showing that you do know how to find the information of this from a cumulative frequency graph. Right, well I'm going to put that as 149, that as 154, and that as 158. So let's put that information on a box plot. We've got the lower quartile is 149, so let's put that. How's this going? This is going up in 2, so that's going to be there, 149. The upper quartile is 158, which is going to be there, so there's the box. The median is at 154, which is there. The tallest girl is 175, so that's gone off of here, hasn't it? And the shortest is 130, so that's gone off of there. When you compare box plots, or box and whisker, they must have the same scale, which these have. So now we can do a comparison between the information. Let's just fold that over so I can get the two a bit closer together. So we can make several comments. The median, or average median, is greater for the girls in year 9, which would be expected. The spread, the interquartile spread, is very much the same, if not exactly the same, but the main comment you can make is that the overall spread from the smallest, the shortest to the tallest is far greater. The idea is to make some comparisons and some comments, and that would be my comments.